So I do a part 2 of this video on domain of a function. The reason I'm doing that is because I want to go through a couple trig functions. I want to remind you also that you're most likely to see something like this on the multiple choice section of the AP Calculus A/B exam. So let's look at this. So the question is here, what is the domain of g of x is equal to 1 over 1 minus cosine of x? And this is just the problem is trigonometric, but the idea is algebraic, that we know, or is arithmetic, we know that the denominator of a fraction can never go to 0 or or becomes undefined. So what we know past that is that this piece down here, this 1 minus cosine of x, cannot go to 0. So we have to find out if and when it does equal 0. So I'm going to do some algebra here, and if we just do this quick algebra, and I'm not going to do it with you, frankly, that we know that if cosine of x is equal to 1, then 1 minus 1 would equal 0, and that would be a domain issue here. So that has to be excluded from our domain set. So now what I want to remind you of is this, and this is the thing that throws people off a little, is that remember that x is theta. It's our angle of interest. We're back in trigonometry, right? We have the unit circle here, right? We have the unit circle here. The unit circle has a radius of 1. It has these points, and remember that the x, y coordinates are the cosine sine coordinates, and we have the point 1, 0 here, and that point exists at 2 pi. So every time we go around this circle and we get to any interval of 2 pi, from 2 pi, or from 0, we're going to have a domain issue. So what that says to us simply is this, that our domain, and this is going to get weird for a second, our domain is x such that x cannot equal 2 pi, right? But it can't equal those coterminal angles of 2 pi either. So if we went around the unit circle, so let's say we start at 0, we go here, we're at 2 pi, right? And we go around again, right? We're at 4 pi, but that cosine value is this one, right? So we have to have some multiplier in there. And the one that's most characteristically used is n. So 2 pi n, and let n equal some integer. But that is assumed onto you. So there's no big trick here except for to remember, one, that you're back in trig, two, that the denominator of a fraction can't go to 0 without being undefined, and that this, it says cosine of x here, but this is a theta value, otherwise known as an angular value, and we have to go back to the unit circle and track that thing down. And the next example is even a better example of that because it gets a little bit more complicated, and that one is this. And the question is this, what is the domain? So we're looking for the domain again, and we're looking for the domain of this function, and this function is, let it be h of x, I guess, is equal to 1 over sine x minus 1/2. Now, again, my first concern always is this thing down here. So I'm looking down here, and I'm saying, if this value down here ever gets to 0, we're going to have a domain issue. So we have to take that out of our domain. So I'm just going to break that out, and I'm going to ask myself the question: when is sine of x minus 1/2 equal to 0? Right? So this is going to be fine. It really is. But we have to really think about this. So going to solve and get, well, sine of x is equal to 1/2. That's just the algebra of it. Now again, I'm back at the unit circle, right? And I happen to know that this angular value right here, this angular value here has a sine value of 1/2. So it's 1/2 here, right, is the sine value. And I think it's, what is it, 3 pi? Yeah, it is. It's 3 pi halves is the cosine value. That doesn't matter, but this is the value that does matter here. And look, if I go straight across from here, I'm going to get something over here. I'm going to get negative 3 pi halves over 1/2. But all we really give a crap about is there's the sine value again, right? And there's the sine value right here of this one. So what are those angles? The way that you should know this is you should have memorized, frankly, the unit circle. This value here happens to be, what is it, pi sixths? It is pi sixths. So it's pi sixth, pi sixth. And this value right here is 5 pi sixth. Right? We're using radian values because we're in trig. So we know that any time that we get here, the sine value of this angular value will be 1/2. So our domain will be equal to x is not equal, right? Is not equal to pi sixth plus 2 pi n. A lot of calculators, I'm going to say this again, a lot of calculators are running it this way, and I don't know why that's necessary. But I'm saying to you, if you're at pi 6 and you go around, this is 360 degrees, so if you're at pi 6 and you go all the way around the circle again, you end up back here again, don't you? These coterminal angles. Or x cannot equal, and x cannot equal 5 pi 6 plus 2 pi n. All right? So these domain values are arrived at through exclusion, aren't they? Okay, I hope this was really helpful for you. Keep working. If you have comments or questions, please let me know, and I'll do my best, and I'm hoping that you're subscribing.